is polynomials, quadratics, a lot of stuff like that. It is not scary, horrible, bad. A lot of the first few things that we're going to do is, again, basically all review of what we did in algebra 2. Did it work out okay for you?
Not really. That's moving on.
Oh, no.
Yeah, well, that's. It was just a challenging ACT.
Ah, yes. So what we're going to be doing here is, like I said, it's a mixture of a bunch of the stuff you guys did last year in Algebra 2. And it's going to be graphing, it's going to be finding zeros between factoring, it's going to be synthetic division, it's going to be some long division, complex numbers, you know, the imaginary stuff. It's a real good mix of a lot of stuff. It is, Fontana and I were able to spend a good chunk of time on Friday planning out basically the rest of the semester. And I can tell you,
Did you have to come to work on Friday?
yeah, we did. Yeah. What I'm looking at with you guys is that we will probably be, it'll probably be like next Friday. We'll have our first quiz, which will be over just the first 3 sections. So
Next Friday?
next Friday. So we have basically 8 days to get through 3 sections. Is what we're planning on doing. Okay, so it's a nice slow pace through a lot of this. After that, then we start getting closer to the parent-teacher conferences stuff. So I know for that Wednesday before conferences, we'll have another quiz. And then when we come back, we have another couple sections, and then we'll have a test after that. So we're looking at being done with Chapter 2 around the 18th, 19th of November. So I mean, and there's only 6 sections. And that's like almost 5 weeks from now. There's plenty of time to get through all this stuff. So don't worry. As most of you guys noticed that, I mean, the stuff that you guys did, your tests and everything's all graded, that's all in there. Most of you guys did fairly decent on it, so there wasn't really any major concerns. There were a couple of questions here or there, but once these obviously are done, I'll get them back in your hands. Hopefully tomorrow we can go over a couple of them. What I want to do today, though, is just to talk about graphing quadratics. The couple of ways that you do it. There's the 3 methods and stuff. So let's take a look at good old-fashioned quadratics. You guys, wow, this didn't show up normal at all. When we dealt with quadratics last year, you had your ax squared bx plus c. That was the most generic way of using the quadratics. And when we did that, those coefficients, those a, b's, and c's, allowed you to figure out certain things with their graphs. So we had f of x for quadratics was ax squared plus the bx plus the c. Every single one of the quadratics, when it's an x squared, sorry, this is all crooked, you guys driving me nuts. No. Anyway, just stand on one foot, it'll be fine. What happens here is that if it's going to be a quadratic, you get a parabola. And all these parabolas are symmetrical. They're all symmetrical when we're dealing with an x squared parabola if about some imaginary axis. That imaginary axis went through the vertex of the parabola. Remember they either opened up like a cup or down like a frown?
Yeah.
It was up like a cup if A was positive, it was down like a frown if A was negative. Okay. What we did there is that you were able to find this, we'll call that axis of symmetry by a one little step. Do you remember that? Good. Yeah, that's it. Opposite of b over 2a. So the first thing we always did with the quadratic is to get what was called that axis of symmetry, the AOS. And that was found at x equals the opposite of b over 2a. Why did I write it as x equals?
Because it's on
Because it's a vertical line. It's about the x, right? Therefore, your vertex is this x coordinate, comma some value y. How did you figure out that value of y? If you were doing electrical work, you would plug stuff in, but for substituting, you every time.
Okay, what I said was perfectly right. But that worked.
Okay. when you had quadratics, you had maximums and minimums. Maximum is the what? The highest point. The minimum is the? Dun, dun, dun. So this would be your max, and this would be your min. The maximum and the minimum is also the vertex. Tells you the x coordinate, tells you the y value, what the maximum value would be, or the maximum or the minimum value. Last year, you may or may not have done a lot of the quadratic word problems where you're trying to maximize cost, maximize revenue, things like that. You might have done a few of them towards the end with the modeling stuff, but it really all depends on how far you guys got. We will spend a good day on quadratic word problems as we get into it. Probably, what would that be? Thursday, I think. A lot of the word problem stuff, yeah, but a lot of the stuff that we do, it's all calculator stuff. It's all the idea of how do you utilize the calculator to make sense to figure out the values. It's all looking at the tables. It's so ridiculously simple. I'm not lying to you.
We understood that about last week's.
I don't even know how to use a calculator.
Well, that's a good thing that we're going to learn. All right? We're going to get it. I promise.
Okay. Do we have
Okay.
to graph like sign?
Eventually. Eventually. That's second step. Okay.
But it's not like review.
Should be. Start with. But we're going to do the inverse trig functions this year.
But he said that next month is the offset, right?
It is, but we start with the stuff that you already know. We'll start with unit circle, we'll start with the radians, we'll start with graphing sine and cosine, but then we're going to do the arc sine, arc cosine, which is basically, we talked about it last year. I don't know if you were with us, and then we had your sine curve, we were just doing the inverse parts of it. It's really easy to do. So basically what I want to do, forgot it. The other form of the quadratic was good old standard form. What's up? I'm all right. Very happy man. This is just like bonus territory. It's just ridiculous.
We'll see how we feel tomorrow. I'm a little nervous with the wind blowing out and hand stretching.
Yeah. But it's more a cross breeze though, isn't it?
It's straight out the west now, so that'd be going straight out to right field.
That's not good.
No, we don't win.
No.
Go cards go.
There's always one.
Fail.
If I had to go through, no.
I was the only one cheering at B-Dubs last night.
The other way of doing this was your standard form, your A, H, and K. You guys vaguely remember A, H's, and K?
Yeah.
We did it. Jeez. Where your H and K is your vertex. Okay. It opens up if A is positive, it opens downward if A is negative. You're still able to get your axis of symmetry. It's just the value of X. Or excuse me, the value of H. Whatever that is. When we dealt with this stuff in terms of standard form with the H and K, what we generally did was we got our vertex, figured out what direction we were going to go, and just pick a point next to it and get, remember what were called symmetric twins?
No.
Well, I'll show you when we get an example. Every parabola, when you have that axis of symmetry, no matter where it is, this point here is the same distance to here as this point opposite it. These are called symmetric twins. Okay, you fold it over onto one another. All right, they're the same. They're equidistant from that axis of symmetry. So what we did was we would just pick a couple of points to the right or to the left of the axis of symmetry just to do a quick substitution. Most of the time you can do it in your head. It's really quite simple. Okay. And then the last form that we did last year, I believe, was the intercept form. Remember that one? What?
I'm talking about your
Yeah.
We're saying that you actually did a good job though.
Thank you.
Besides the time. The colors match what the patterns flash.
Yeah. Story of my life. Intercept form. Do you guys remember what P and Q stood for?
No.
Not quite. What were the P's and Q's? Intercepts. Those are the zeros.
Oh, yeah.
Those are the intercepts. Hence, intercept. These are the zeros, where P and Q are your zeros. What's nice about this method is that this is a real common one for some of the word problems. Where let's say you were selling something for 20 bucks, you would sell, if you sold gym shoes for $20, you'd sell 8 pairs a month. For every increase of $2 price, you'd sell 1 less shoe. So you're able to create a quadratic in terms of units with this. And that was a real common thing that we did last year in Algebra 2. Very, very common style problem. We actually have a couple of those in here as well, just to remind you how they set up. But what happens with the intercept form is that you get 2 zeros, you're going to be able to figure out where the axis of symmetry is rather easily, and its vertex, because those intercepts, you got to just get their midpoint, and that gives you your x value. Okay? It's going to be really, really easy to work with. And like I said, a lot of this is review, guys. A lot of it is review. Excuse me. So, let's graph this. Let's sketch the graph of, well, I guess we don't need to go to the standard. Are they calling that standard form the AH? Okay, I just want to make sure they don't.
I feel like it would.
Yeah, they
That
were
would be
using
perfect.
standard.
That is, but I think this book calls that standard. Yeah, they call it standard. Okay.
Wait, so which one's standard?
All right. Standard is what you guys are used to calling your, yeah.
We just.
I'm going to go by what the book says. All right. So what this one is calling their standard is the AH and K. All right. Now with this one, I think it's this one. No, this is Coleman's because he's an idiot.
Where was it?
All right, whose book do you have?
Remember I lost?
Oh, that's right.
Hey now. Woohoo! Want that one back?
Yes, please.
Thanks, Mr. Murphy.
You're welcome. Now, one of the trick ones that you guys did last year, if you had to get it in that standard form, what you have to do is you're going to create a perfect square. Which means, like, complete the square.
I don't remember how to do it, but I know it's easy.
Okay. So let's do this. We have, was it 2x squared, 8x, and 7. What we need to do is complete the square. All right? So basically what we do is the following. We take the 2x squared plus 8x plus blank. Oh, actually, you know what? Write it out normally first, and we're going to set it equal to 0.
I like the concept, well, because I don't watch baseball. But
So-
I've always-
Actually, you know what? We don't have to do ours. Oops.
I just don't watch baseball.
Let's do this. In order for this to work, when we do this completing the square thing, one of the rules you guys had to have is that your x squared term had to have a coefficient of 1. Vaguely remember that? Right. So what I'm going to do here is this. I'm going to take the 2, I'm going to have x squared plus 8x plus 4x plus blank. Okay?
Maybe there's something.
Yeah. And I'm going to move the 7 over to the other side for right now. By moving that over. Now, here's the other trick. One of the things that we did there is that we factored out some value of 2, which means we have to put it back in on the other side. Remember that? When you factor something out, you have to put it back whenever you completed the square?
Yeah.
So we're going to have this plus 2 times something over there. Okay. That's how we're going to factor it through. Okay. Now let's complete the square stuff. You take the value of b, and what's half of that?
2.
So here's what's nice. What we're doing is that whenever you take half of b, that value goes into your term, goes into your parentheses. So it becomes 2, x plus 2, quantity squared. What you're doing is we're creating a perfect square out of this. You need to get something that's going to be the same. X plus 2, you get x squared plus 4x plus 4. All you do is you take half of this value of b, whatever that is, whether it's positive or negative, it drops into your term. When you square it, you're adding it in to both sides. Yes, sir?
Is it always going to be b divided by 2?
Yes, sir. Always. Always, always. It's always going to be b to half of b. Okay? Excuse me. So now,
And you get 1.
what's that?
You get 1 on the right side.
Correct. You get the 1 on the other side, which means to get it back into that whole standard form or intercept form like we're used to seeing, we just move it back over and you're done. So you get f of x is going to equal 2 x plus 2 quantity squared minus 1. That way you can identify your ancient k. It's just another way that they have you do it. They have you do it via, well, what we're used to calling the intercept form, sorry, vertex form. They're just calling that now your standard. Okay. Thanks, sir. That's all it does. By using that completing the square method, I know that there are shortcuts to doing that. I might have added a couple of steps in there by setting the side equal to 0, moving things back and forth. Trust me, if you shortcut it, it's not the end of the world, but make sure you do it right. I'm going to try and keep going just kind of a little bit of the longer way to do it. That's all. I think this might be as goofy as any of the stuff that we look at for today, to be honest with you. So this tells you your h and k would be at -2, -1, and it's got to open up. And the reason that it has to open up is it is positive, thank you. That's really all there is to it, okay? All right. Let's try another one like that. Let's grab another one. Come on. We'll work it off. There we go. So let's try it a different way. Let's just graph this the way it is. Let's go through the way that you guys were first taught. If I look at this and I want to graph it the way I was taught, I have y equals -x squared plus 8x plus 2. And this is going to be one of those ideas that I would have you, I'd have you graph this without a calculator, okay? And I'll show you how you do this. A couple things that I would do, especially since it's been a while since I've had to do this by hand. Label them. Take a second, label what you know. Your A, B's, and C's. Manny already said it's got to work its way downward because the A value is negative. So it's got to be down like a frown, which means the vertex is going to be a maximum or a minimum. It's be a maximum. It's got to be a maximum at its vertex. So when you go to graph this then, well, start with your axis of symmetry. Your axis of symmetry is always going to be the opposite of B over 2A. So you get -8 over -2, which is 4. Okay? So we're starting with just that. Notice I have not given you graph paper. And that's okay. What's that? So we'll start at 4. So there's my vertical asymptote, or excuse me, my axis of symmetry at x equals 4. I know my vertex is going to be at 4 comma something. So what's 4 squared? 16. So we have -16 for our first term. 4 times 8 is 32 and negative 16 is 16. 16 plus 2 is 18. So my vertex is at 4, comma 18. What's that? How do I get that? All I did here is I took this value of 4 and I substituted into y. Or excuse me, into x to solve for y. So I have negative 4 squared plus 8 times 4 plus 2. And I just did them part by part, that's all. So 16 squared, negative 16 and 32 is 16, 16 and 2 is 18. Okay. Now, obviously, 418, I can just say it's right there, right? Without much of a hassle. Now I want to get a couple sets of symmetric twins. Well, Yep. Because 4 squared is 16. Make it negative, so it's negative 16. 4 times 8 is 32. Negative 16 and 32 is positive 16. 16. What would the value of y be if x is 0? 2. It's your value of c. So at 0, I have a 2. How far is that away from your axis of symmetry?
2. Wait,
Wait, how'd you get that?
that's 4. Never mind. That's 4.
It's 4. Wait, how did I get that?
No, but like, yeah.
What's 0
You're
plus
paying
0
attention.
plus 2? What I'm doing here is I'm picking really easy numbers to work with. Knowing that, and one of the things you guys will notice is that that value of c, that's always going to be your y-intercept. Always. All right? That's a nice thing to remember. Now, if this is 4 spots away at 0, 2, what's 4 spots away over here? At 8 and 2. Those are symmetric twins. Okay? Those are your symmetric twins. I know it's falling. Okay? Hey, sir, there's fine. Thanks, sir. So that's just another one of the methods of way of doing this. It is really, really easy to do. We have our vertex, set of symmetric twins. It's a maximum, it's a minimum, whatever which one it is. You got your axis of symmetry, and you go for it. Okay?
So like, where can you just put that?
Well, I should do 2 sets of twins. So let's just use 1. What's 1 squared? So so make it negative 1. What's negative 1 plus 8?
7.
What's 7 plus 2?
9.
So at 1, it's at 9. Which means at 7, it's also 9. See how easy it is to pair them off with symmetric twins by just using really easy numbers. You shouldn't need a calculator. Okay? Vaguely remember that? I'm hoping. Alright. Let's try the intercept form then real quick. Let's graph it out of intercept form. So if I have y equals x plus 4, x minus 1, that means I'm going to have zeros at,
X plus 1, or negative 4.
perfect. I'm going to have zeros, intercepts if you will, at negative 4 and positive 1. I also know that this is going to open what direction? Why? What's the value of a in this case? 1. A is the first one, for parentheses. So here's the deal then. What happens in between, halfway between any sets of ordered pairs, or twins, for parabolas? The midpoint, which would be the axis of symmetry. So basically, no matter what, whenever you're at zeros here, what we're going to do is find the midpoint. So what's negative 4 plus 1?
Negative.
What's half of that?
1.5.
Negative 3 over 2, right? Negative 1.5? Yeah. I hope. So at negative 1.5, is it okay if I write it as negative 1.5? You guys gonna be mad at me if I do that?
No.
It really doesn't.
Might be happy.
The only times that I usually use the decimals is if I'm not doing anything else with them. Okay. If I'm just labeling something, I can write it as negative 3 over 2. I can write it as negative 1.5, whatever. I know my axis of symmetry would be at x equals negative 1.5, and I just go from there. So if my axis of symmetry, that means my vertex is going to be at negative 1.5, comma something. Excuse me. So what's 4? You had $4, but you spent $1.50 on your phone. You have how much?
Wait, what? Almost question.
You have $2.50. What's negative 1.5 minus 1? Negative 250. So what's, this is going to be, what's 25 times 25? Remember that? 25 squared? Is it 6 1/4? I think. Is it 6.5?
Yeah.
I'm trying to just do this in my head and move my decimals around, so it should be 6.25. Or, if you press buttons on your calculator, wouldn't you make that work?
Yeah.
Watch what you can do with the intercept form. It's pretty cool with your calculator. Oops. Yeah.
Oh, you changed your picture.
I did. Moose was having a, Moose got his Ninja Turtle pajamas. He got his Ninja Turtle costume yesterday. It was awesome.
I don't think that
It's got
you
like a
like your other
backpack for like it's got the muscle one and all that. It's got the turtle shell you fill with like newspaper, so it like fills up real big and all that. He was walking around the house like, yeah, it was awesome.
I think that you like him more than your other kid.
Oh no. Oh, speaking of the other kid, Connor, you get a tall
The
one.
other one.
Connor, we were up in the Dells for the weekend. Took the kids to the water park, stuff like that. And we were eating dinner. Connor also.
Did you go to Moose Jaw?
No, we didn't go to Moose. This time we didn't go to. Ryan loves Moose Jaw. We didn't go there this time. He sees. He goes, "There's my restaurant. I'm the Moose." He sees the Moose. He loves that place. But we were eating dinner, and Connor goes, "Hey, I got a joke for you guys." I'm like, "What is it like?" Now, mind you, he's 6.5. All right. He goes, "What do you call a cow with no legs?" Ground beef. He just started. He lost it. He totally lost it. It was so funny. Anyway.
Never like mentioned your background. You never tell stories about him, except for that one.
Who? Connor?
Yeah.
The other one.
The other one?
The unloved child.
The other boy.
Yeah.
He's not.
Moose is definitely the favorite.
Whatever. All right, so it's negative 1.5. What was it? Plus 4? Close the parenthesis, open a parenthesis, negative 1.5 minus 1, close the parenthesis. Notice, I'm typing it in my calculator exactly the way that it was written if I was going to substitute
Didn't
in.
you tell us that we weren't allowed to use our calculators?
Well, sometimes.
Sometimes.
Even if I give you a dummy calculator to do some of this stuff, would that be okay?
Yeah.
Sorry.
The same idea here. Because when it comes down to using the graphs and being able to do a lot of stuff with or without the calculator, I find that if I give you guys the regular multi-views or just the regular TI-30s, as long as you know how to use the parentheses correctly to substitute in, it's not that big of a deal. It really is. I would prefer if you could do this stuff in your head, but what I'm saying here is we might not have to worry so much. So let's see. We had negative 1.5 and then negative 6.25, which is about here. So our vertex, is that a maximum or a minimum?
A minimum.
It's a minimum because it's got to open up like a cup. Now what's nice is that we also can use 0
Oh,
again.
I did it backwards.
I can use 0 again to find another set of symmetric twins. Since my intercepts are already my zeros, they're already one set of symmetric twins, to find another one, pick a really easy number. Well, 0 is very close. What's 0 plus 4?
4.
What's 0 minus 1? What's negative 1 times 4? Negative 4. So I know that at 0, negative 4, Well, this is gonna be 1.5 away from my axis of symmetry. Do you guys agree?
Yes.
What would be 1.5 away on the other side?
3.
3, good, -3. And there's my stuff, there's my curve. All right. Did I read? Thank you. Okay, and go from there. Let me ask you this. What if you graphed that on a quiz or something like that, you started labeling your other set of symmetric twins, and you wrote -3, 4, but you have it at -4 and it's symmetric with a -4 on the other side? Would I yell at you and mark you wrong?
Yes.
No. Seriously, I'm not gonna lie. No, I wouldn't, because you know what you're doing, you plotted it in the right spot, you just forgot the negative. I might just put it in there and say, be careful or something like that. I mean,
What
it's,
if I accidentally graphed it the wrong way?
then I would mark it wrong, and
With this.
okay, and I would do that. I'm trying to think if there's any other. That's really all I wanted to do with this stuff today. What I did have is I did make a homework-ish sheet over the course of the first 3 sections. It's kind of like a rough draft, and I left them on my desk, so let me go grab that. Realize I didn't put the page numbers on here. I'm going to leave it up to you to figure out that section 2.1, you would look in section 2.1.
Whoa.
I know, I'm asking a lot, especially from you.
I would have been the one to ask for a page though, so it's okay.
So the 2.1 day 1 is basically, like I said, we're just graphing. The instructions ask you to sketch the graph. Where's the axis of symmetry, things like that. Tell me if it's a vertex, where the vertex is it a maximum, minimum, things like that. Tomorrow we'll talk about the factoring stuff, working through all those. And then, like I said, Thursday we'll get into some of the word problem junk. This is kind of a rough idea of where we're going to be at over the course of these few days and stuff. There might be some additions, there might be some subtractions and whatnot kind of broken here, but this is kind of the idea that I was looking at to do over the course of these first 3 sections. All right. Questions at all on that? I mean, it's kind of rough outline, but you get the idea.
That's a no.
Sorry, it's not typed. Don't hate me.
Well, I just wasn't expecting.
You weren't expecting. So let's see. So.
Mr. Murphy,
Yeah,
not going to be here tomorrow.
I'm very sad.
Okay, so here's
Well, no, I